is the one really juicy golden raisin in a loaf of dead brown raisin.
Raisins.
Yeah.
Every opportunity I had to talk to Deep, I bothered him. So he'd like go to the fridge. He'd go to the fridge and like drink water and he'd be like, "Hey, what's up, man?" I'd have a question locked up, like in my holster. Time travel. How do we do it? Carl Anderson.
Lance Roylo.
Deep, are you there?
Oh, hey, what's up?
Oh, what's going on?
Hey, Deep, it's Carl. Just wanted to say thanks for doing this, and also it's great to meet you.
Yeah, nice to meet you too.
I guess we'll officially start. So, Deep, can you tell us like a little bit about yourself?
Yeah, sure. I'm a grad student at the Institute for Astronomy at UH Manoa. I kind of grew up always wanting to do astronomy, and so I went through undergrad, and then I was like, okay, I want to go to grad school. I want to do astronomy, and so a few stops along the way, and I've ended up at UH, and I'm working on my PhD there.
Can you explain the in the movie? All right, we'll go to the movie stuff. In the movie Interstellar, right?
Yeah.
I remember talking to you about this, and you were saying that the black hole scene where they're like entering the black hole. How did that come to be again? I think we talked about it. Like it was accurate, or it was accurate.
Yeah.
Somewhat accurate.
So they got a lot of supercomputer time to actually try to generate what a black hole would really look like. And I think at that point, that was the realist example of, it's hard to get like supercomputer time because it's really expensive, but if you're a Hollywood movie, you have a huge budget. And so the folks working on Interstellar had a huge budget, and they were able to work with scientists to get a really good representation of what a black hole looks like. And so that was like a really interesting like intersection where of Hollywood and science, where they were able actually, I think there's a paper that came out of that too. I don't know too many of the details, but
so yeah,
that's crazy.
So they were that this is an actual a really good representation of not visually, but the mechanics behind a black hole.
Yeah. The visualization, like the colors and stuff, are not so real. It's been a while since I've seen the movie, but like the actual physics that's going on there is my
yeah, because quite possibly they just wouldn't see anything. It would be black.
Well, so the black hole itself is black, but there is a disk of material around the black hole that does glow.
Really? And it's not a disk; it's a sphere, because a disk in 3D is a sphere, right? That's
sort of. So there is a main disk that things fall onto. So if you think about the way stars form, or a solar system like ours form, right? You have the sun in the center. Sun obviously is spherical. But then you have the planets that lie sort of in a thin plane, right? Most of them are aligned on the same plane.
Kind of like the rings around Saturn or something, right?
Right, exactly, yeah. In a similar fashion. And so just the way the laws of physics work, things tend to congregate in disks around bodies when they're sort of spinning. And so the physics works out the same way around a black hole. So the disk of material around a black hole, which is called an accretion disk, that there is material that glows, that it has light, and you can actually see that. So you can't see the black hole itself, but you can see what's around it.
I see. And that light doesn't escape, because I thought that all light, even light, can't escape the black hole. So we would still be able to.
Right.
Okay.
Yeah, so there's a point called the event horizon, and so once things are past that point, they can no longer escape. But before that, in the, sort of the outer parts of the disk, you can see that. And actually, so there are sort of two types of black holes. There's like the type in Interstellar, which is like a stellar mass black hole is what you call. It's basically when you have really, really massive stars, at the end of their lives, they go supernova, they explode, and they turn into a black hole. Those are sort of like, those are, maybe a few times the mass of our sun. That's kind of the size we're talking about. And then there are the sort of aptly named supermassive black holes, which lie at the centers of galaxies like our Milky Way, and those are millions to billions times the mass of our sun. And so the one in Interstellar is a stellar mass black hole, but you also have really massive supermassive black holes, and those are very, very bright. At least the disk around them, depending on what's going on. And so if you have the region around a supermassive black hole that's very bright, say there's been a lot of recent activity there, it'll glow really, really bright, and we can see those way far out early into the universe's history, and so those are some of the brightest objects in the sky.
That's pretty amazing, and they've theorized also that they're incredibly old if the light is reaching us now, right? Those supermassive ones, they're oldest.
Yeah. So there's some that are close, as in relatively close by, but a lot of them are very, very far away. And so I guess we're sort of on the top. We're sort of skimming around the topic right now, but basically, the further you look back physically in space, the further you're also looking back in time. And so, light is almost like this, because light has a finite speed. And so what you're basically doing is looking back, into a time machine, because the way you see those really, really far away objects, you're seeing them as they were a long, long time ago.
Right. So they don't exist. So some of them don't, like, we're seeing them now, but like a lot of those things probably don't even exist anymore. Is that what you're saying?
They probably don't exist in the same state anymore. They don't just disappear.
Right.
Right. Like, so when you look at the sun is about 8 light minutes away. People talk about like light years, but the sun is about 8 light minutes away. So you're seeing the sun as it was roughly 8 minutes ago.
Yeah. So what?
And so it could have disappeared, and we'll find out in 8 minutes if it disappeared or not.
Wait. So when we see it, so when scientists say like, "Hey, you got about 8 minutes to get your affairs in order."
Well, we wouldn't ever know. You wouldn't ever know, because it would take 8 minutes for it to happen. It's just gonna, it's gonna snap and it's gonna happen.
Oh yeah.
The sun's not going anywhere, but we wouldn't have any advance warning.
I see.
It would just happen.
Yeah, because there's nothing faster. Like there's nothing faster than light yet.
Right. You can't move information faster than light. That's the quickest notification you're gonna have, basically.
So Deep, I like where you were going with the time, especially time as like a tapestry, if you will, where you can, theory of relativity, right? And just like knowing where things are on, like, if you will, a map of time. But can you talk about Interstellar? And I feel like I haven't read much about it or even seen articles on it, but the how Hollywood has made that theory of time, right? When they were on that planet where, I guess what is every hour is like 7 or 10 years. I forget the number.
But the ocean planet, right?
The ocean planet, yes. Is that...
Yeah, it's been...
Is that Hollywoodized in a sense?
No, not really. I mean, it's Hollywoodized in the sense that, it's been a few years since I've seen the movie, but didn't they almost get like washed over or something?
Oh, yeah. I mean, taking all of the stuff that happened on the planet.
Taking all the drama aside, yeah. No, it's that is a feasible scenario where you have, so the idea there is that, feels like I should have watched the movie just before, just to prep, but if you have, say a planet in that instance, in the presence of a really massive body, like that black hole, which was it called Gargantuan, I think, if I recall. Basically what really massive bodies do is they warp space and time around them. And so what is happening in that instance is time is passing differently if you're really close to that massive body than it is, if you're somewhere else in the universe. And so that, the passage of time is affected by, say if you're near a black hole. And so that is totally fine. There's nothing, that is a realistic scenario.
Okay. I think that was the whole point of that movie. They were trying, that was like the big reveal was that, oh, gravity is the key, right? That's how he was able to communicate with his daughter previous in time, was through gravity. That's the one common factor, I guess, that they were talking about.
Yeah, I don't really remember the daughter stuff, to be honest.
Oh.
But but the physics there, in terms of, what's happening there on the planet, in terms of the passage of time, that's totally legit. Yeah.
Very cool. Now I know this is probably something we're going to skip around a little bit here, Deep, but I know that, and we can probably get back to the time stuff later, but what I want to, while it's fresh in my head, we were starting to talk about light and the distance, or the time distance that light travels, right? Now, when I say Gene Roddenberry, does that like make hairs stand on the back of your neck?
That rings no bells. I'm not gonna lie.
That's all right. That's all right. Gene Roddenberry. Oh man, you're gonna hate me, Deep. I'm telling you. Gene Roddenberry is the creator of Star Trek. And,
okay. I don't watch Star Trek. Yeah.
So FYI, we lost Lance, but he'll probably be back on in a second.
Okay. Yeah.
I just noticed. Yeah. But okay. So Star Trek. I know you don't. I know you're back, Lance.
Yeah. Sorry about that.
That's all right. So we're still talking about Star Trek, and so Gene Roddenberry created this entire series in the '60s, Star Trek, right? And each episode was really grounded in some sort of theoretical physics, astrophysics. These are the ideas, right down to and I guess these theories in the show were so profound, but yet kind of grounded, that a lot of research was done afterwards based on some of these ideas. But one of the biggest ideas that came out of it, obviously, was faster than light travel. Now, I think a lot of people already, or maybe they don't. I remember I was talking to Lance. What do you know about faster than light travel?
Not much. I think I saw a. Granted, I'm like watching YouTube videos, that there was a school here in the United States that took video of, like, they had like super high speed cameras or something, and they showed that there might be, or there is something faster than light, possibly, or something. Does that sound familiar, Deep, at all?
So there are like hypothetical particles that, people have just sort of theorized, called tachyons, which are faster, which would, be faster than light particles. Field of expertise, but my understanding is, like, there's no real good evidence for the existence of any faster than light particles. So, the idea of faster than light travel is really a big problem if it were to exist, because you would, the speed of light is
directly
essentially sort of
the maps.
It's essentially, the universal speed limit in the universe. You can't ever go faster than it. And
I love
a lot of the
Deep. I love how you put that.
Yeah,
I love how you put that. It is the universal speed limit. I love that. I've never heard it.
I'm sure other people have said that, but
I've never heard that either, actually.
Yeah.
But yeah, you would, if you were to able to somehow go faster than light, you would start breaking, our understanding of physics would break down very, very rapidly. But, there is really no good reason to believe that we can, or particles do travel faster than the speed of light. It's kind of just a, conjecture at this point. It's
Yeah.
interesting conjecture because, how would you have to change physics to match sort of reality? But my understanding is it's kind of out there. It's not really any sort of realistic
Yeah.
thing.
Well, yeah, in Hollywood, the cheat is the antimatter machine. So, and
Yeah.
how Star Trek has explained it is they have these warp engines, basically, if you will, it's like a train, like a railroad, and the railroad is the tracks are light, and the big wings that go off of the starship or whatever ship that they're using, they are able to attach physical or mass to the light. That was the cheat. That's how Hollywood has
Okay.
cheated. Like, instead of making mass go the speed of light, we're attaching something to the rails, and that's they already talked about tachyons. So.
Yeah, I mean, so again, I've outed myself as someone who's never watched Star Trek. I think I maybe saw one of the movies once. I don't remember.
I'm with you, Deep. I don't watch it either. So.
I'm not
Deep,
a good astronomer apparently because I've
that's
never
okay.
seen Star Trek. But
Deep, I can actually see you sitting there watching Star Trek, like making the jerk off sign with your hands, like, oh, this is all bullshit, guys.
no, I think
Come
I have a lot of friends who watch it and enjoy it. I've just never bothered to sit down and watch it.
Okay.
All
So-
right, it sounds like a
Movie
terrible
is
movie,
that?
like
No,
a terribly
it's-
depressing movie.
It's so good because it has a Disney ending in the end. They're like, oh, they finally get off the ship, these few humans, and get to populate, and then all of the cannibal humans drown in the ship underneath the ocean. So,
All right, that's something.
What movie is that?
I'm gonna,
What
you know
movie
what?
is
I'm
that?
gonna.
Who's
It's
in
so
that?
good.
Okay. I never heard of that.
It's so good.
Okay. Look it up. Okay, let's go to the next movie type connection I want to make. Have you seen Armageddon or Deep Impact?
I've seen both. It's been a while since I've seen either of them, but I've seen both.
Me too. We're so I like both movies. It's been a long time. Actually, I saw Armageddon again maybe in the last year because I really like the Aerosmith song, and it's a Michael Bay film, so stuff blows up. So let's
not forget, like, it's one of the few Michael Bay movies that actually touched my heart when Liv Tyler's just like, Daddy. She says goodbye to
Bruce Willis. So okay, let's say hypothetically there's a meteor heading this way, and I know there's a lot of different ways that we could possibly deflect it or use a gravitational pulley, I guess, to kind of take it off course. Like, what are all the ways that you've heard, and which one do you think is the way to go on, in your opinion?
Sounds like you know the way to go. The idea is to slightly nudge it out of the way. Basically, if you catch something early enough, you only have to move it slightly out of the way to basically not have it impact Earth, right? Because the longer you in its orbit, the closer it gets, the more you would have to nudge it out of your way, right? Think of it as, throwing like a baseball, right? If you're throwing it from really far away, you have to be really careful about your aim. Otherwise, it's going to go in one direction or the other. But if you're really close, you can just sort of lob it over to a person and they'll catch it, right? So the idea
is
the
it
same.
more like a... Oh, go ahead, Deep.
So the idea is that basically the same thing. If you catch it early enough, you send some sort of spacecraft to it, and basically the idea is that spacecraft that you send has some mass, and so it would attract the asteroid or the meteor or whatever, and so you just slightly nudge it out of the way. You let it, just inch it, and that's all you need.
I mean, like, how far? Let's just say hypothetically, like, we find out that like a year from now or whatever, it's going to hit Earth. Do you think that we're capable of like doing that? Because I know Japan, I believe last year, the year before, they landed on one, and I'm not sure exactly what they did, but I mean, couldn't we just do what they did and then add like some kind of propulsion system to that rocket to that whatever landed on the meteor or asteroid, and just like you said, like move it an inch, pretty much.
Yeah, I mean probably more than an inch, but yeah, you just bash it a little, and if you can know it's coming in your direction, you could hit it any which way, and it's going to go somewhere else. Doesn't care if you hit something else, you just don't hit Earth.
Yeah, I heard that. I heard that like solar sails, which I don't even know what that works. I mean, from what I understand, the solar sail is like a reflective material or something, and that the sun's power or the sun's heat like powers it, and then that could maybe shift it, or we could, I mean, going even further into the solar sail thing, we could even traverse like, the universe using solar sails. I'm not even sure what that is exactly.
So I think, well, solar sails, is basically huge solar panels in space, right? And so in terms of traversing the universe in space, that gets very difficult because sure, you can send up a probe with sails right now, and it'd get a lot of light from the sun, but once you're at like the distance of Pluto, you're not getting too much light from anything. And so it's an idea you could use sort of within the solar system, but if you want to go outside of the solar system, you sort of run out of your power source, right?
And so essentially, if you did that, you could, I mean, like if you knew that your solar sail needed something to energize the panels, could you just be like, okay, the first place we're going to go is around the sun, get some energy then there's some other planet that we know, or star that has energy you can give, and just like kind of like plan your course using the stars, pretty much.
The problem I see there is storing the energy, right? Because say you did a loop around the sun, you collected a bunch of stuff and you put it in sort of whatever battery, basically, and then you go off to Alpha. You say you want to go to Alpha Centauri. Well, you could have just sent up a probe with a charged battery and send it to Alpha Centauri, right? You didn't need to loop it around the sun. So the idea is you don't want to have to store your energy. You just want to be able to use it as you go. Does that make sense?
Yeah, that makes sense.
Yeah, and so the problem is like the parts of time where you don't have enough energy, because the amount of radiation you're getting from the sun goes as 1 over the distance squared. And so if you're twice as far away from the sun, you're getting a quarter of the energy. And so, you're out at the distance of Pluto, which is much further away. You're getting a very small fraction of the light you're getting on Earth. Yeah.
So Lance, it's sort of like, hey man, I got to charge my phone. I'm going to go to these different cubicles and I'm going to go to CVS and plug in my phone. And you're like, dude, I'll just meet you there with a battery pack.
Got it. Yeah. Okay, now that makes sense.
Yeah, and so, look, I don't know these numbers off the top of my head, but Google does. So Pluto is off 40 times the distance, that Earth is right now. And so 40 times the distance, you're getting 1,600 times less solar radiation you are at the distance of Pluto. So it's basically nothing.
Hey, Deep, this is not what I didn't really want to chat about, but just you're really quick. Is we still refer? I notice a lot of scientists still refer to Pluto as as a unit or to compare something to, even though we've taken it off the charts as a planet.
Yeah,
but people still
right.
Well, Pluto. So it's like, why don't we we just call it a Pluto? Yeah, right.
Yeah. No, that's a fair point. I think we just grew up, Pluto was the furthest planet, and now it's not, but you still sort of use it as the benchmark, I guess.
Yeah. Okay. By the way, guys, that movie is called Pandorum, and it was done in 2009. Just when you get a chance, take a look. Watch the trailer. I've just given you the epic reveal, so sorry for the spoiler. I know you're not going to watch it anyway, but
what's the
29%. Oh man, that must be. 29% Rotten Tomatoes. 28% Metacritic, and Dennis Quaid is in it. I mean, yeah.
So
the budget was $33 million, and the box office was $20 million. So
yeah.
That's a winner in my book, if I've ever.
Okay, so I'm gonna say this, and I think Deep will understand. The movie itself was a steaming turd. However, the ideas behind it are pretty fucking amazing. I mean, like the reveal at the end is like, oh yeah, we figured it out how to move this massive bunch of bodies to a different planet, and the computer, because of an energy problem, is slowly waking up these humans that are in these pods. But unfortunately, it's like it's being used as food for the mutated cannibal humans on board. And then, okay, I'm going to stop talking about Pandora.
29.
I might give the trailer a watch just to see how bad it looks.
Yep. Just know that the idea is pretty cool.
Okay. Well, one of the main actors in this movie is Kung Lee, who's a kickboxer. So that's always, that makes me feel confident that it's a good movie. He's a great kickboxer. At least
entertaining.
I'm sure he's a great actor too.
Hey, Deep, and one more thing. So I know we were talking about before, and I didn't want to skip around, but I know that Lance and I could use some of these sound bites, these great pieces of gold that you've given us, and thank you. But one of the ideas of traveling to different places, as Lance aptly put it at one point, he's like, oh yeah, they could freeze us or something and move us into space. But these wild theories of us in time being able to transfer our consciousness into something that's not organic, and traveling to different places is probably how it will happen, right? Because it's the physical limitations of our bodies. But I like to subscribe to your idea, and I know it's another idea, but yeah, generations living on these ships, or however we get there, learning, until we get to the place of choice, because once we finally get there, then we have to adjust from how our bodies have changed from spaceship. And then we have to, if the actual planet is truly viable for life, right? There's a lot of things, to consider, right? If that was the case.
Yeah. I'm not going anywhere. Put it that way. I'm not going to sign up to do any of it. Yeah. So, I mean, I don't know. This stuff is, conjecture on, but I think we're really so far from doing. I mean, we haven't been back to the moon, and how long has it been? A lot of years.
30 years? Or no, wait,
No,
30 years.
Yeah.
I don't think we've been back since the 70s.
Yeah.
In terms of humans, at least. And so I think we've got a number of things to do before then, and I think there's a really, folks talk about going to the moon and then going to Mars, and that's okay, but going outside of the solar system is really just a whole nother big, it's a huge leap that I think is, it's not like, okay, we went to the moon, we went to the Mars, the next step is Alpha Centauri. That's not a step, that's 50 steps. And unfortunately, space is really empty, and so there's not a lot of stuff in the way. There's not a lot of intermediate things you could even do. It's just space is empty and
fast.
Yeah, and hey, why do we want to go to Mars anyway? Because I know there's in the media they talk about colonizing Mars, but that's not realistic, is it? That's not practical.
It's not unrealistic. I mean, we could do it if we wanted to.
But why though? I mean, is there I'm kind of with Carl. I follow Elon, and he's super excited about it, and I get why people are excited about it. But I'm kind of what's the practical? Why is that practical? Why?
I'll give you my opinion on it. So some people say, hey, we're messing up this. Go build another one before we screw this one up.
Right.
It's probably easier just to not screw this one up.
Yeah, it seems like. And then I remember watching the movie. I watched I'm sure we've talked about it too deep. Is the movie The Martian with Matt
Yeah,
Damon?
Matt Damon.
Like that made me like not. I was like, do we really want to live there? I don't want to pee on my own plants and then eat them. And you know what I mean? Like it didn't seem hospitable. So
it's not. And there are people have ways thoughts on like how to terraform Mars to make it hospitable. And that's something we could probably do if we put our minds to it. But
it is
so in the immediate in the immediate future, there's no any of this, right? So climate change aside, the Earth is not going anywhere anytime soon. But eventually it will, right? So the sun right now is about halfway through its what's called its main sequence lifetime. It's basically right now what it's doing right now is it's burning hydrogen in its core into helium, and the byproduct of that is the energy and the radiation that you see. And so it's sustaining itself on that right now. But at some point, the hydrogen in the core is going to run out, and the star, to make up for that, it's going to have to undergo some structural changes, and it's going to become what's called a red giant. And so it's going to poof. It's basically going to poof up, and it's going to be a really big, fluffy star. And it's going to sort of come out basically, to where Earth is, basically. And so Earth is going to be toast. It's about 5 billion years off. So we've got a little bit of time.
Oh, good.
But that's the only okay, we have to do something. We've got 5 billion, T-minus 5 billion years. We have to do something before then.
Yeah, I thought you were going where I'm going to reference another decent movie, maybe. But it's
another 20% Rotten Tomatoes movie coming up.
Well, it's a Danny Boyle film. So
okay. So
Sunshine.
Slumdog Millionaire, sweet. No,
I've heard about Sunshine. I haven't
Sunshine
seen it.
is cool. Sunshine is cool. I didn't like the end though, Carl.
Why?
Don't you think that was weird? Deep, you need to see it, and you tell me what you think. I think I thought it was a little weird. They're all go ahead.
So basically, the idea is that our sun hasn't burnt. It didn't burn out to the point where we get fried. It has. It dies off. So the sun is now no longer radiating the kind of energy, and actually to the final scene, is they show people in Australia, where it's like Siberia. It's like a frozen wasteland. Like the entire Earth has been frozen over. People have gone underground to stay warm. Right. But it all takes place aboard this ship, which are they solar lamps? They're not solar sails, but they block the sun. The idea is that they're traveling. They are traveling in the ship to get close enough to this dying sun to reignite it. They've found the whatever chemical composition to reignite the sun.
Okay, what do they do? They nuke the sun or something?
Something. It's like a chain reaction, whatever the cheat is in Hollywood. We found a way to reignite the sun, but it's a ragtag team of scientists basically who have to get close enough to the sun, which is still pretty freaking hot. So they have to have these shields that kind of can move to block the solar the radiation from frying the actual ship to get close enough. And then what lands is, it turns into a horror movie. I mean, it's a great science fiction movie up until the end, where it's just basically a Michael Myers on the ship. Right.
Yeah. I think it gets weird. It gets so weird. I was so into it, and then it happened and I was like, what is going on? This is not what I thought it was going to be.
Yeah, but it's in Danny Boyle fashion. So if you know Danny Boyle's work, Slumdog, but also was it 27 Days Later? He redid
the zombie movie.
Oh, he did that.
Yeah.
Or 28 Days Later, yeah.
Movie. 28 Days Later.
Yeah,
20 Days Later. Yeah.
That's a solid movie.
I love that. Not to go off topic, but running zombies. Oh my god, my favorite.
Oh no, so he reinvented them. It's like not the and they're strong still. It's not right.
Yeah, the ones that
they're
like
not
kind of
soft.
Yeah, and they're not like just walking slowly, where you can just walk at a fast pace, and you're like, all right, well, they're not going to get me.
Yeah. But Deep, you might like this. You might like the premises and the ideas behind the movie because they do talk a lot. 3/4 of the movie is all about theory and educating the audience on how they're going to do what they do. So unless you're kind of like a science nerd, it's like a lot of it's like my wife was not interested in all this tech talk. Who gives a shit? She's what she said. But I'm like, this is so cool, right? So,
yeah.
Anyway,
do you watch those movies, Deep? And you're like, do you watch them? And I mean, do you enter? How does it work? Because like me and Carl and most people, we can entertain the idea because we are probably like, maybe this could happen. But like for you, knowing like, no, like this can't happen. Are you automatically shut off from movies like that?
I think that, there's no reason you can't have a good movie and have it be scientifically accurate, right? There's no, those two things are not in conflict with each other in any means. There are, we've talked about Interstellar, we've talked about The Martian. They're pretty solid on the science, and they're both really good movies. It sounds like, you could, not to point any fingers, but Armageddon, for instance. It's a fine movie, but like the best way to get rid of the asteroid is not to blow it up into 1,000 pieces. That's not the best idea. I don't know. So I think it just comes off as lazy, basically. Like it's not, it's not that difficult to hire, a scientific consultant and be like, hey, does this script make sense? Right. So
Deep, I'm gonna have to disagree with you. I think an oil rigging crew is the perfect solution to pushing an asteroid away.
But it almost goes hand in hand, sort of, right? Like if you're gonna put in the effort to hire science consultants from the beginning while you're writing the script, like you probably also care about all the other, and so you're probably gonna make a great movie, right? Yeah, so
it sounds like a James Cameron kind of way to go. Like that's money and kind of just figure or who's the Christopher Nolan? Yeah,
that's exactly I mean, when Michael Bay did it, he's like, I'm sure somebody at one point said to Michael Bay, we should really have them as scientists. And then Michael Bay's like, no, how's there going to be any conflict? What is Bruce Willis going to do? Nobody's going to believe Bruce Willis is a scientist.
That makes sense. Or Ben Affleck.
Yeah, they want some sort of conflict. Like scientists would take it seriously and say, nope, let's not blow it up and let's not land anybody on this asteroid. We're going to do it the scientific way.
I guess it kind of makes for a boring movie if you're trying to figure out where to send a spaceship to, nudge the asteroid out of the way. I get it.
Yeah, because then what you get Deep Impact.
Yeah, Deep Impact. I liked it too. It wasn't as like exciting, but like Carl and I were discussing earlier this morning is how it was. What did you say, Carl?
I said Deep Impact is the female version to Armageddon. It's like it's the same script, but no. This is the more gentler version. This is the girl version.
Yeah, because it's like more about like the scene that always hits me in my head is when Tia Leone is hugging her father on the beach.
Yes.
And the wave is like, it's coming and they just hug each other and eventually it sweeps them away. That part, I always think about that part. And I live near the beach now. And I'm like, if it ever hit, I'm going to have one of those moments. Where I just see the way 1,000-foot wave.
Yeah. Deep Impact got a 45% on Rotten Tomatoes and Armageddon got a 39%. So it barely just.
All right.
Wrong then.
Close enough.
Close enough.
What is your favorite space movie, Deep?
If
you have one.
I don't know.
Sorry to put you on the spot.
No, well,
Yeah,
I
I don't know.
mean,
I think The Martian's really good. I quite like The Martian. I think so. I don't know if y'all have read the book, but it kind of the ending is a little dramatized in the movie version, which is fine, right?
mm,
But like it's pretty good. The Martian's a pretty good movie.
What do you think about Gravity? That was pretty realistic, right? With their hair not moving. with, the, with Sandra Bullock's hair not
I don't really.
moving
I
at
think I
all.
just blocked most of Gravity out. It was
Really?
most of my brain.
Did
Yeah,
you
I
as a
wasn't a
movie you
fan.
didn't enjoy it?
As a it's just forget the science. The movie was just whatever.
The part
I honestly don't really remember what happened. Was she like dreaming half the time? I don't remember.
I will tell you this, Carl, have you seen this movie?
yes, of
My
course.
my favorite part, and the part that kind of took me out of it, was when she's like kind of just floating through space. I think her tether got unconnected from
Okay.
Yeah,
the
right.
main space station, and then she's using a fire extinguisher or something like that, and she
Oh,
tiny space station, and I'm like, okay, yeah, so they're just a couple meters away. Like that
And they
doesn't
just
even
happen
make
to be,
sense.
yeah.
They happen to be a couple meters away, and she has just enough fire extinguisher, whatever propulsion system she was using, to get
To
there.
get
And I
there.
was like, oh my goodness,
Yeah, I
this
don't
is
even remember
and
this
she
part.
ridiculous.
she would only need just a little bit too, and it would like the momentum would keep her going
But the
anyway. She
fact
didn't
that
have
he
to use
was even
everything.
the fact that he was
I know,
even there though, like it was close. And
I
speaking of,
know.
I had this argument with my roommate Deep. How
Mhm.
how so in that movie Gravity, there's a whole thing on the whole kind of the mess that happened was due to space trash, I guess, moving. They're like, according to the movie, they're moving like bullets through space, and they can go through like your suit and through spaceships and stuff. Is that an
Yeah, so there's a lot of
actual
junk up in
thing?
space.
Do they move that fast
Um,
though? Is it like if you go to the wrong whatever, like they're just bullets pretty much?
so it's not just like if you go up to orbit, it's raining bullets, right? It's not like a minefield. Um,
Oh, okay. That's the way
right?
that they hit.
It's not quite. I honestly don't remember what happened in the movie, but it's not quite a minefield up there. But it is an issue. Like space junk is an issue because um, we have instant. Like I mean, people just launch stuff up there, and I think now people are trying to get better about having sort of like you when you're making a mission, you plan how you're going to decommission it. Basically, what you usually do is you let it burn up in the Earth's atmosphere or something like that.
Yeah,
But
because isn't there, from what I understand, there's more than like I don't know, 500,000 pieces
there's
estimated
a
of
lot of garbage up there.
yeah, that can travel up to like 15 to 17,000 miles per hour. I'm not sure how much of this is, BS or not, but those are the facts that I.
Those numbers sound about right.
Oh God.
Don't quote me on but like yeah, there's a lot of trash up there, and you don't want something hitting the Hubble Space Telescope.
So how do
Right.
they?
You don't
So
want.
how does that work then? Like, how do they? I mean,
I
obviously
mean, so
there's
there are
math
people
involved, but
monitoring this stuff. Especially like the big pieces. There's like we have a decent sense of what junk is up there.
Mhm.
And so if the need arises, you can do a sort of maneuver to get out of the way, kind of thing. But as space travel gets easier and easier, it gets cheaper and cheaper to launch things up in orbit. This is something that folks need to be careful about.
How does that work exactly, Deep? Do they? Is there like a space rule or law or something where you're going to go, hey guys around the world, I'm going to launch these satellites. They will
So
decommission themselves, or does everybody just do whatever?
So first of all, there are space lawyers that will know the answers to these questions. There are people who, go to law school and then specialize in space law. Um,
Oh,
I just
I
pictured a dude in a spacesuit with a tie and a briefcase floating.
Space law.
So there are space lawyers, but also like a lot of this stuff is just unregulated. There are suggestions. There are, I think, if you're launching like from the United States, I think the FTC has rules about like, if you want to launch from U.S. soil, you have to follow so and so rules. And I think a lot of different countries have those rules, but I'm sure there are ways to get around them. We're sort of on a related note. A thing that's becoming an issue is things like Starlink. Are you familiar with Starlink?
Yeah,
basically, Elon's little
satellite
pet project to give everyone internet.
Yeah.
So these little small satellites, and the idea is you cover low Earth orbit with them, and you provide everyone with internet, right?
Mm-hmm.
Problem is there's a lot of them, and they're really bright. And so they're showing up actually in like astronomical images all over the place, just ruining data.
Are they up there now?
And that's because
how so?
Oh yeah, they're up there now.
How is it ruining data?
If you take an exposure, say you're taking an image from the ground, it's 30 seconds long. You're looking at so and so star. One of these will just buzz across your screen, and you've integrated your camera for 30 seconds, and you've got streaks across your image.
Oh god!
And they're very, very bright. I mean, you can see these things with your naked eye.
Wait, really?
A lot of these are very bright. Yeah.
So what is it? Is it like a
and
string?
They're brighter when they launch.
It's like a string of satellites, or how does it work?
So they're sending up multiple, I think they send up like, I don't know, 100 of these at a time. So it looks like, I've just Googled it, they've launched 540 Starlink satellites. But they're up there, and they're kind of getting in the way of, it's not a huge problem right now, but there's only 500 of them up there. I think Elon wants tens of thousands of these, right? And if Elon wants tens of thousands of these, Bezos is going to want tens of thousands of these.
Yeah.
And all of these rich people are going to get into, they're
putting up satellites, right?
Trying to keep the language PG.
No, that's the whole thing.
Things. Things are very unregulated in space. Is basically what I'm trying to say. It's still kind of do first, ask permission later.
It's still it's still kind of like the Wild West, is what you're saying.
Yeah, it really is. And I think SpaceX has made some efforts to reach out to astronomers. Well, maybe it's the other way around, where astronomers like, hey, SpaceX, you need to get your shit together. You can't, keep doing this. And I think they've made some adjustments, but it's still kind of an issue for some telescopes than others, right? So if you have a telescope with a really wide field of view, you're covering more area of the sky, and so you're more likely to get one of these in the way.
And when it costs money to take these pictures, like, if I were like somebody working on a project, and then you see this thing, I'm like, motherfucker! I would see it. I'd be so upset.
Yeah, I mean, a night, so we're the Institute for Astronomy, and there are telescopes on Mauna Kea. A night on Keck, if you incorporate what capital costs and cost to run the telescope, a night on Keck is probably like $50,000-$60,000.
Yep.
Yeah. Wait, a month?
And
a month?
A night.
60,000 a night?
Yeah.
Oh my. Okay, never mind.
That's what I was saying. It's like when we're taking pictures, it costs
cost of right. And so that includes like construction costs, amortized over like 50 years plus operating costs. But yeah.
Hey, Deep, have you seen the movie Ad Astra? It's one of the most recent ones. Okay. That's another one where, take the storyline out of it, which is kind of a steaming turd as well. It really is.
It's like Brad Pitt, right? It's with Brad Pitt.
Yeah, and Tommy Lee Jones. It's basically a daddy issue story. It's hard for my head to wrap itself around. How do we measure where the edge of the universe is that is expanding? Because when you say that the universe is expanding, I picture us I picture us in the middle of a balloon. And when you say it's expanding, somebody is blowing up that balloon, right?
We're
And we're in the
not
middle of
in
it.
the middle of the balloon. We're on the surface of the balloon.
Okay, that just
Yeah,
surface of the balloon.
That's a pretty So there's sort of one dimension missing, right? So we're breaking it down from 3 dimensions to 2 dimensions, but as you blow the balloon up, there's more space. Say you take a balloon, it's not blown up. You stick a bunch of dots on it. You take a Sharpie, you put like 5 dots on it. Each of those is a galaxy, and then you blow up the balloon. The space in between each of those dots is getting bigger.
And each of the dots represent a galaxy?
Sure. Yeah. Whatever. A galaxy.
Okay, but within so within our own galaxy, since the whole thing is expanding, are we also getting further from other planets too?
No, because at some point the self-gravity of objects is strong enough to withhold the expansion, right? Like I'm not expanding, you're not expanding. And that's because the molecular forces that hold our body together are stronger than gravity. Gravity is actually a pretty weak force. And so, the scale at which this happens is basically groups and clusters of galaxies. So our local group of galaxies, which consists of the Milky Way, and also Andromeda, and then a bunch of other smaller galaxies. So that is our local group of galaxies, and that will remain bound forever.
Wow.
Okay, I did not know that balloon thing blew my mind. I was like,
no, that blew my mind too.
I thought we were inside, but then you said the surface. So I was like, okay, this is a whole different.
Yeah, I think another analogy people use is sort of like raisin bread. I don't use it because I don't like raisin bread, but like before it's baked, if the raisins are galaxies, you bake the bread, it becomes bigger. And that way it's more of a 3D structure, right? And so basically the raisins are getting farther apart from the other raisins, but that's because there's more bread. Like the bread is poofed up. And so that bread represents space. And so basically there's more physical space in between the galaxies.
To consider anything outside of the crust is kind of like...
it's forbidden fruit right now.
It's for...
We may never know what's outside the crust of the raisin bread. No, for sure. Well, anyways.
Yeah, and thanks again.
Yeah, Deep. Thank you so much.
Yeah, chatting was fun. So. Yeah, that sounds good.
Yep. Okay.
All right. Thanks, Deep.
Thanks, Deep.
Yeah, it was pleasure meeting you.
Yeah,
nice chatting,
same. Take care, folks.
Yeah, you stay safe over there.
Out there.
All right, man. See ya. Bye. Bye.
Goodbye.
Carl.